Sometimes it's the simplest ideas that pack the biggest punch.
Oh, absolutely.
And that's what we're diving into today.
Okay.
The K-nearest neighbors algorithm.
KNN.
Yeah, or KNN for short.
Right.
It's been a powerhouse in machine learning for decades, and it's still going strong.
It's amazing how KNN just mirrors how we naturally understand the world.
Really?
Like, we automatically group things based on what's similar, right?
Makes sense.
Birds of a feather flock together.
Exactly.
And that's, like, the foundation of KNN.
Okay.
It's all about data and finding those patterns.
So imagine you're trying to tell the difference between two birds,
Okay.
like an American robin and a gray catbird.
Classic problem.
They look similar, they sound similar, but,
Yeah.
you start measuring things, wingspan, weight, beak length,
Right.
you start to see some distinctions.
You're basically creating a map,
Oh, interesting.
a data space, we call it,
Okay.
where each bird is plotted based on those characteristics. Even if some measurements overlap, the robins and catbirds,
Yeah.
they end up forming their own distinct groups.
So we've got our robins and catbirds in their own little clusters now.
Right.
How does KNN actually use this to figure out what a new bird is?
Let's say you spot a bird you've never seen before.
Okay.
You can measure its wingspan, weight, beak length,
Right. Get all the data.
and then see where it lands in that data space.
Like see who its neighbors are on this map.
Exactly. That's where the K comes in.
Ah, okay.
We choose a number for K, let's say 5.
Okay.
The algorithm looks at the 5 birds closest to our mystery bird.
Based on those measurements.
Yes.
So if most of those neighbors are robins?
Then KNN would predict that our new bird is probably a robin too.
Makes sense.
It's all about finding the similarities.
But how do we figure out closeness when we're not dealing with actual distances?
Good question.
Like, are we talking miles, kilometers?
There are a few ways to measure distance.
Oh, really?
Sometimes it's simple, like measuring a straight line between points.
Okay.
Like how your phone finds the nearest coffee shop.
Right.
That's Euclidean distance.
Makes sense.
But what if you're comparing articles based on their topics?
That's way more complex.
We might use something called cosine similarity.
Okay.
It's less about physical distance and more about how much they align in direction.
So are two articles pointing towards the same theme?
Precisely.
Interesting.
So it's not always about literal distance, but about finding those relationships.
Okay, we've got the neighbors part down.
Right.
But how do we pick the right K value?
That's the million-dollar question.
Is there a magic number?
Unfortunately, no magic number.
Or
Choosing the right K is a balancing act.
how so?
A small K might make our model too sensitive to outliers.
Like that one friend with totally different movie tastes.
Exactly.
So it skews the results.
A large K, on the other hand, might miss those important local patterns.
It's like trying to fit in with the whole crowd and missing what your close friends are up to.
Yes. It's about finding that sweet spot.
So what happens if we get the K value wrong?
Well, if K is too small, our model might overfit the data.
Overfitting.
Yeah, meaning it's great with the data it knows,
Right.
but fails to generalize to new data.
So it's like memorizing the answers instead of understanding the material.
A perfect analogy.
And what if K is too large?
Then we risk underfitting.
Underfitting.
The model becomes too simplistic.
Okay.
It misses those important nuances in the data.
So finding the right K is critical.
Absolutely.
Are there any ways to help us find that sweet spot?
Data scientists use methods like cross-validation.
Cross-validation, what's that?
We test different K values on a subset of the data.
Like giving our KNN model a practice run.
Exactly. It's all about finding the K that performs best.
Okay, so we've got a good grasp of the theory.
Yeah.
But where do we actually see KNN making a difference in the real world?
Oh, KNN is everywhere.
Oh, really?
Think about those movie recommendations you get on Netflix.
The ones that are eerily accurate.
That's KNN in action. It uses something called collaborative filtering.
Collaborative filtering.
Yeah, it's like having a friend who knows your taste perfectly.
That's a pretty cool.
And it's not just for movies.
No.
It's behind product recommendations on Amazon, music suggestions on Spotify.
Wow, so KNN is behind all that.
It's all about analyzing patterns and finding those connections.
So it's not just about entertainment, right?
Definitely not.
Where else do we see it?
KNN is used in healthcare,
For real.
like for medical diagnosis.
Tell me more.
Imagine doctors analyzing a patient's gene expression data.
Complex stuff.
They can compare it to similar patients.
So they're looking for neighbors who share similar characteristics
Exactly.
and seeing if those neighbors developed a certain disease.
Yes. It can help predict disease risk and personalize treatment plans.
So KNN is helping doctors make more informed decisions.
Absolutely.
Incredible.
There's even a research paper from 2001 by Guion et al.
Good.
It shows how KNN can be used for cancer classification.
Wow, that's amazing.
So yeah, from recommending movies to potentially saving lives.
KNN is a real multitasker,
It is.
but I'm guessing it's not perfect.
You're right. No algorithm is perfect.
What are some limitations of KNN?
Well, one thing is that it can be a bit of a data hog.
A data hog.
It stores all the training data,
Okay.
and when you're dealing with huge data sets, things can get slow.
So it's like trying to find a needle in a haystack.
Kind of.
Too much data can slow it down.
Exactly.
What else?
KNN can also struggle when there are tons of features,
Features.
like different variables in your data.
Okay.
It can be hard to find meaningful distances between data points.
Too many variables can make it confusing.
Exactly.
So that's where feature scaling comes in.
Right. Making sure all the features are measured in a comparable way.
All right, so we've covered a lot of ground.
We have.
From the basic idea of things that are alike tend to cluster together
Right.
to real-world applications that are shaping our world.
It's fascinating, isn't it?
It really is.
And this is just the beginning.
There's more to come.
Oh, yeah.
What's next in our KNN deep dive?
In the next part, we'll get into the practical stuff.
Okay.
Data preprocessing, fine-tuning parameters, evaluating models.
Sounds good.
Stay tuned. We're just getting started with our KNN adventure.
Can't wait. Welcome back to our K-Nearest Neighbors deep dive. Still with me?
Still here.
Awesome. Now, last time we were talking about these movie recommendations.
Yeah, those ones that just seem to know you so well.
Exactly. Turns out it's not magic, it's KNN.
KNN is like that.
Really?
A Swiss Army knife for data analysis.
Okay, I like that.
It's super versatile, can do so much.
But like any tool, you got to know how to use it.
Exactly. And that's where data preprocessing comes in.
Data preprocessing.
Yeah, getting the data ready for KNN to do its thing.
Okay, but what does that actually mean?
Well, remember how KNN is all about distances?
Like finding the closest data points.
Right, but imagine trying to measure distance between two cities, but one's in miles and the other's in millimeters.
Oh, that's going to mess things up.
Totally. You got to have everything on the same scale.
Right, like apples to apples.
Exactly. That's where feature scaling comes in.
Feature scaling.
It's like converting all our measurements to the same unit.
Okay, so how do we actually do that?
There are a few ways, but two popular ones are normalization and standardization.
Okay, normalization and standardization.
Normalization squeezes all the features into a range between 0 and 1.
So everything fits in the same box.
Exactly. Standardization, on the other hand,
Yeah.
it distributes the data around a mean of 0 and a standard deviation of 1.
So everything's kind of centered and balanced.
Exactly. That way, no one feature unfairly dominates just because its numbers are bigger.
Okay, that makes sense. So once we've scaled our features,
Right.
we're ready to roll with KNN.
Almost. We still got to pick that K value.
Oh, right, the number of neighbors.
The Goldilocks problem, remember?
Not too big, not too small.
Precisely. This is where we fine-tune our parameters.
Parameter tune.
It's like trying on different outfits to find the perfect fit.
Okay, so we've pre-processed the data, tuned our parameters, now what?
Now we got to see how well our KNN model actually performs.
You mean put it to the test?
Exactly. This is model evaluation.
Model evaluation.
We want to know how well it handles new, unseen data.
So can it apply what it's learned to something it hasn't seen before?
Exactly. It's like a student taking a test on new material.
Not just regurgitating memorized answers.
Right. One way to evaluate is accuracy.
Accuracy, what's that?
What percentage of predictions did it get right?
Okay, sounds straightforward.
But sometimes accuracy isn't the whole story.
Really?
Why not? We also got to look at the types of errors it makes.
Different kinds of error.
Precision tells us of the positive predictions, how many were actually correct.
Like, did we flag all the spam emails, but maybe accidentally caught some important ones?
Exactly. Then there's recall.
Recall.
It's about minimizing false negatives.
So, not missing any actual cases of a disease, even if it means a few false alarms.
Precisely. Depending on your goal, you might prioritize one over the other.
Or try to strike a balance.
Exactly. It all depends on the specific problem you're tackling.
Okay, so we've got data preprocessing, parameter tuning, and model evaluation.
Those are the key steps.
The building blocks of putting KNN into practice.
Right.
But can we see some real-world examples? Like, how does all this actually play out?
Of course. Let's go back to those Netflix recommendations.
Right.
Netflix has this massive database of movies and user ratings.
Tons of data.
And you and another user rated similar movies highly.
So we become neighbors in the movie taste space.
Exactly. And Netflix can then suggest movies that your neighbor loved but you haven't seen.
Like a personalized watch list curated by someone with my taste.
Precisely. It's not just Netflix, though.
Oh, right, you mentioned Amazon and Spotify too.
It's all based on that same idea of finding similar users and recommending things they liked.
Okay, that's pretty cool. What about healthcare?
Yeah.
You mentioned KNN being used for diagnosis.
Yeah, imagine a hospital wants to predict a patient's risk for a disease.
Okay.
They have data on the patient medical history, genetics, lifestyle.
Lots of information.
They can use KNN to find similar patients in their database.
It's looking for neighbors with similar characteristics.
Exactly, and seeing if those neighbors developed the disease or not.
So, by analyzing the outcomes of those nearest neighbors, doctors can get a better idea of the patient's risk.
Precisely, and make more informed decisions about prevention or early intervention.
That's amazing. KNN is helping to potentially save lives.
It's incredibly powerful.
And it's not just healthcare, right?
Nope. KNN is used in finance, for credit scoring, fraud detection, even predicting stock market trends.
Wow, it's like a data detective uncovering all these hidden clues.
That's a great way to put it.
But are there times when KNN isn't the best tool for the job?
You're right. KNN isn't a magic bullet.
What are some situations where it might not be the best choice?
Well, remember we talked about it being a data hog?
Yeah, too much data can slow it down.
Yeah. Exactly. If you're dealing with millions of data points, it might not be the most efficient.
So sometimes you need a different tool for those really big jobs.
Right. And if the relationships in the data are really complex and not clustered neatly.
KNN might struggle with that.
Exactly. KNN works best when things fall into distinct groups.
So it's like having a reliable friend who's great for many things, but sometimes you need a specialist.
A perfect analogy. It's all about understanding the strengths and limitations of each tool.
And choosing the right one for the task at hand.
Exactly. And as technology keeps advancing, we're seeing some really exciting developments that could make KNN even more powerful.
Oh, like what?
Imagine combining KNN with other algorithms to get the best of both worlds.
So the simplicity of KNN, but with the ability to handle those massive data sets.
Precisely. And as computing power grows, we might even find new ways to tackle those high-dimensional data challenges.
So even though it's been around for a while, KNN is still evolving and adapting.
Absolutely. Just like that reliable friend, always surprising you with new depths.
All right, so we've really dug deep into the practical side of KNN today.
From data prep to model evaluation.
And we've seen how it's used in the real world.
Making a difference in all sorts of areas.
It's been fascinating.
It has. But our journey's not over yet.
There's more.
Oh yeah, in the final part, we'll step back and look at the bigger picture.
The bigger picture of KNN.
Its place in machine learning, ethical considerations, and what the future holds.
Sounds intriguing. Can't wait to hear more.
Stay tuned. It's going to be good.
Welcome back to our K-Nearest Neighbors Deep Dive. We've explored how it works, how to use it, even some of its quirks.
It's been quite a journey.
It has. But now I'm curious, where does KNN fit in the grand scheme of machine learning?
The bigger picture.
Yeah, like what category does it fall into?
Well, KNN belongs to a category called supervised learning.
Supervised learning, what's that?
It's like teaching a student with labeled examples and then seeing if they can apply that to new situations.
Okay, so like with our bird watching example.
Exactly. We showed KNN a bunch of robins and catbirds, all labeled with their measurements.
And then it learned to classify new birds based on those examples.
Right. And within supervised learning, KNN is considered a non-parametric method.
Non-parametric.
Sounds complicated.
It's not as scary as it sounds.
Okay, good.
Basically, it means KNN doesn't make strict assumptions about how your data is structured.
So it's more flexible.
Exactly. It can adapt to all sorts of relationships, even messy or nonlinear ones.
So it's not trying to force the data into a specific mold.
Right. KNN is more about uncovering those hidden patterns without being told what to look for.
Like a detective following the clues wherever they lead.
I like that. But even the best detectives have their limits.
We've talked about KNN struggling with massive data sets and high-dimensional situations.
Right. So when does it actually make sense to use KNN over other algorithms?
Good question.
Well, KNN's simplicity is a huge advantage, especially if you're new to machine learning.
It's a good starting point.
Exactly. You can build a solid understanding of the core concepts without getting lost in the weeds.
Precisely. Plus, it's easy to explain how KNN works.
And that can help build trust in the results.
Absolutely. Transparency is crucial, especially as machine learning becomes more integrated into our lives.
But as we've discussed, KNN does have those limitations.
Those massive data sets and complex relationships can be tricky.
So it's about choosing the right tool for the job.
Exactly. KNN might be perfect for some tasks, but for others, you might need a different approach.
Makes sense.
And the exciting thing is, technology is constantly advancing.
Oh, yeah.
We're seeing some really cool developments that could push KNN even further.
Like what?
Imagine combining the intuition of KNN with the efficiency of other algorithms.
A hybrid approach.
Exactly. Get the best of both worlds.
So the simplicity of KNN, but with the power to handle massive data sets.
Precisely. And as computing power grows, we might even find new ways to tackle those high-dimensional challenges.
So even though it's been around for a while, KNN is still evolving.
Absolutely. Just like that reliable friend, always full of surprises.
Well said. I think we've covered just about everything there is to know about K-nearest neighbors.
From those bird-watching analogies to the real-world applications,
It's been quite a deep dive.
it has. And I hope our listeners have a new appreciation for this deceptively simple algorithm.
Me too. Because at its core, KNN is about more than just classifying data or making predictions.
It's about seeing the connections, right?
Exactly. It reminds us that sometimes the most valuable insights are found right in our own neighborhood.
Beautifully put. And with that, we wrap up our deep dive into K-nearest neighbors.
Thanks for joining us, everyone.
Until next time, keep exploring and keep looking for those insightful connections in the data all around us.